Hello and welcome to another Solana tutorial. Today we're gonna learn something. Yes, we're gonna do that. Specifically, we're gonna have a look at how to deploy a program to an address that has been created with system program create account. And if that all sounds complicated, then that's because it is. No, it's probably not. I mean, if you're new here, then it might be. But I do have videos, old ones. I'm gonna put them here. Look, I can put them all the way up here. I have long arms this time because I'm so big. What was I saying? Oh yeah, a video on the create account with seeds. Create account with seeds. We've been talking about that, and program deployments, that's, what you do in order to get your Solana program on chain or to deploy your smart contract, as they call those things on other networks. And my goal is to combine that, the deploying a program to an address that I created with seeds. And maybe that's super trivial and easy, and we're done here in 10 minutes. Could be. But maybe, and that is actually more likely, we will need to do a deep dive on how program deployments work on Solana. Because I've never actually looked at that really. I've always been like, Solana program deploy, and it just works. But what's behind that? Who knows? Well, people know. I don't. And you might not yet. But that's what we might have a look at if we need it. And that's my preferred way of learning as well, right? I set myself this goal. That's what I want to do. And I have a reason why I want to do that. In this case, I want to be able to do that because if I can deploy a program to an address that I create with seeds, then I can have longer vanity addresses, which is a topic for a future video. I mean, we have talked about vanity addresses in previous videos, but always just creating a key pair with a vanity address or even a ledger address, which is even worse. It's just nice to have a custom address, right? My program, because I just love my vanity addresses. And if I can create a vanity address with seeds, then it's easier to grind that. Shout out to, what's their name? Caveman Loverboy. Dr. KV PhD has recently put out a tweet on how to grind addresses more quickly if you do it for create account with seeds. So yeah, that's the motivation. And now I want to be able to do this. I want to be able to deploy an address to such an account, but I don't know how it works. And therefore I now have the motivation to find it out. And that's how I think you should learn as well. That's how we best learn, in my experience. Actually having something that we want to achieve for whatever reason, and then finding the building blocks to do this. So in this case, what do I need to find out? Well, how to grind those addresses efficiently and find out the right seeds, which is a topic that I do want to look at in a future video. And then how do I deploy it with such an account that I derived from seeds? And that's what we're gonna look at today. Hopefully, it's gonna be fairly simple, but I have no idea because I've never tried. So let's try it. And as always, I like to take you on the journey with me. Let's get started. Clicky, clicky, clicky. Clear. Make it biggie. And make myself a bit smaller. Here we go. First of all, we want to check that we're in a somewhat new-ish Solana version. 1.18.15 sounds new. The current highest is 18.16. Yeah, probably not that much of a difference. I'm fine with that. And if I wasn't, I would run Solana install update. Oh, okay. So actually the 15 seems to be the latest. Fair enough. And to deploy a program, we need a program to deploy. I don't want to create a new program. I'm just gonna deploy something that I already built at some point. The last thing I did, we had this program that we optimized, and in target release, in target deploy, we have the Hello Anchor SO, which is the final build in SBF that I can deploy on chain. So basically with Solana Program deploy, I should be able to deploy this, and the regular way, how I'm used to it, I deploy it to any key pair, is I create myself a new key pair, PG for program, and then I Solana Program deploy program file path. So that's the usual way how I would go. Solana Program deploy with this key pair. Let's run a Solana test validator, because then it's quicker to deploy and also easier to get Sol and whatever. So I get myself another address in the meantime. That's going to be my authority. Config set my key pair to this, and we go to local. Local validator is running. Solana airdrop ourselves 2000 Sol because it's local. Local don't care. And then we can do the thing we said we would do with Solana Program deploy with this key pair and my SO file. Oh, the key pair. Haha, wait, the key pair is the authority. Forget that. That's not what I wanted. I wanted to specify something else. But if I just say deploy this, then it probably deploys it to a new address. Yeah. Wait. Wow. No. It automatically finds this address that I have also in here. The hello anchor key pair JSON. Ah, there we go. Program ID. That's what I wanted to specify. Executable program. Must be a signer for the initial deploys. Can be an address for upgrades. Default is the address of the key pair at program keypair.json if present. That's how it found it. Okay. The CLI automatically checks for that. Otherwise, it takes a random address, and the address can be a base 58 encoded public key. Can be a key pair file, as with this one, a hyphen, which signals a JSON encoded key pair on standard in. Okay, so then I would pipe in a key pair JSON encoded. That would look like program ID this, and now it expects the key pair, but I don't put anything in, so this doesn't work. I would need to pipe in here the program key pair JSON like this. Damn, how did bash work again? Oh wait, no, that's writing files. Hold on. Pipe it in here. There we go. That works. So basically just write the contents of this file to standard output, which I take as standard input for that thing. This part, and that signals it takes it from standard input. So that's how it would work with the piping, which is basically the same as just saying here this PG, read from that file. Then I don't need to pipe anything into standard input. That will do the same. We'll also deploy to this address. And if I don't provide an address like the program ID, then it deploys it either to a new address or to the address that it finds in the program name -keypair.json, which I have in here. So that's this one then. Yeah, that's fine. Can also have it ask for a seed phrase, or I can specify a hardware wallet address. We've been working with ledgers, the ledger and then the derivation path and whatever. You could do that. And if there's a separate update authority other than the key pair, then you can also specify that. So that's all the standard things that we already know. But how, in the world of something, could I deploy a program to an address that I get from system program createAccountWithSeeds? Because that's certainly not in here. And for that, I guess we will need to do some digging, how all of that stuff actually works. So it would be great if we had the source code of the Solana CLI. You know what, I'm gonna just clone this repository real quick. Then actually, I probably want to open a Visual Studio or some IDE. That is taking a while, but that's also a big repo. So Solana CLI, that's what I'm gonna open. Okay, so we have all the source for the Solana CLI. Program v4, program. Because what we're saying is Solana program deploy. So in here we wanna find the deploy. CLI command info, the command is deploy. Okay, there it builds this command info. Then where is it executed? Here, process program subcommand. The deploy process program deploy. Where does that live? Deploy program using upgradable loader. So maybe we should have a discussion about that, or maybe we should talk about that. There are, I think, at least three different programs that are responsible for other programs. From the top of my head, there's the native loader, which is responsible for native programs. Then there's this upgradable loader, the BPF upgradable loader, which is for user programs. And then there is loader. What do you find? So we have the BPF loader, the BPF loader 2, and the BPF upgradable loader. Let's see what those addresses are. So that BPF loader 1, which is itself assigned to the native loader. So that thing itself is a native program. And the loader 2 apparently was an update, but those things don't seem to be used anymore. A month ago. Yeah, no, this is 3 years ago. This stuff is not being used anymore. Because what is used is the upgradable loader, because that will allow you to deploy programs that you can later upgrade, aka redeploy, which is the standard for Solana programs, and therefore everybody will be using this. So yeah, that definitely is used. Few seconds ago, bunch of transactions on it. So this thing will be used a lot. And that's basically the program that allows you to deploy other programs. So when we deploy a Solana program, we interact with a BPF loader upgradable, which itself is assigned to the native loader, which is the program responsible for the programs that are native to Solana, like the system program, compute budget program, and so on. But there's also an effort to move those away to a new loader. But that's again a topic for a different video, so not gonna go into detail here. What we need to know for now is this one is the program that we interact with in order to deploy our own programs, the BPF upgradable loader. Okay, so that thing. Cool. So we have an RPC client, we have a config, program location. I think that's the interesting thing. Program location, default program key pair. If it is a key pair, I have the signer. If it's a pub key, it's give it the program pub key. Else, default program key pair, as signer. Okay, then we check if it is an initial deploy, because that's the interesting thing for us. Once we have it deployed once, it's easy, because now I can also show you that. Now that I deployed it once, I basically just need to say program ID, and I could literally paste in the program ID. Here, paste the program ID of this, and I can deploy there. Why can I deploy there? Why is it enough to give the program ID? Well, because the program has already been deployed, and so the key pair, the signer, is the update authority or the upgrade authority of this program. And that's why it's enough to do that. If it was a new program ID, like, I don't know, I can't just put any random pub key here. It says, well, it requires a key pair to deploy this if it's an initial deployment. And also, if I had a different key pair, like if I were to try to deploy with this one for whatever reason, then it would say the authority, so that was the authority, doesn't match for this program, right? So I need to sign with this in order to redeploy this program, because the authority for this program is this. Anyway, I hope you get this. This is all basic stuff. Point is, only the initial deploy is really interesting. From then it's trivial. Once we have the initial deploy, it's trivial. So do initial deploy. This is the interesting part for us. First, it does some checks, and the result of those checks will be if we need to do a new deploy. So either it's continuing an initial deploy because the account executable flag has not been set yet. First, it does the check if that account already exists and has a different owner or is not upgradable anymore. If it's not upgradable anymore, then apparently the owner is moved away from the BPF loader upgradable program. So there we have an account, and if we don't have an account, then we need to do a new deploy. Okay, that also makes sense. Cool. Okay, buffer provided, we fetch the buffer. So that's relevant. We have this buffer account where we first write all of the executable data into, and then with one transaction, basically we write everything from the buffer into the executable account. So there's the program, which doesn't hold much data, as we saw here. There's not much data in this account, in the actual program account, just where is the program executable. And then in the executable account is the actual bytecode of the program. And that is a PDA derived, I don't even know the details, but it's also an account that belongs to this guy. But in order to write there, this program wants to do it all in once, so it needs all of the bytes. And because there's a transaction size limit, we will need to send a lot of transactions to first write into a temporary account, the so-called buffer account, and then only the final transaction actually writes the program and makes it executable. So here, if we do an initial deploy, now it gets interesting. So basically the CLI says if we don't have a program signer, then you can't do an initial deploy. There is no way to do it with a CLI as the CLI is implemented, because we always need to have that one as a signer as well. Process, program, write and deploy. That's where all the write and deploy stuff happens. Yes, reading method names. Great, Andy. Good job. What's happening here? We get a block hash. So basically, I'm just interested in this. Where is it now? Program sign. Hold on. Program signer, because that's the address. The program signer and the upgrade authority. And the fee payer signer. That's the one who pays for transaction fees. So we can have separate for all of those. That's great. Still, question remains, where is that thing ever used? Only in the final message it's relevant. Before, this all seems to be stuff on the buffer account. Get account with commitment on the buffer. Program init on the buffer pub key. And I don't care which one that is, so you can keep that. Create ourselves our own buffer. Okay, that's fine. Else we create an account for the buffer. So then we create and write messages with the BPF loader upgradable write. That probably gives us an instruction. Yes, it gives us an instruction to write a chunk of the program data to a buffer account. And we probably do a lot of those. So there's probably a loop of some sort. And here we have the for loop for program data chunks. Aha, so the create message is a function. There we go. And here the create message function is called. There we go. There we have the for loop then. So basically we upload those chunks. And then that's the interesting part, the final message, because that's where the actual program account is then written to. If we're talking about the upgradable loader, which we are in this case, here it's an instruction to the BPF upgradable loader, deploy with max program length. Okay, gives us a result for instructions. So can be several, or instruction error. And we put all of those instructions into a transaction message with the fee payer, with our program address. That's the first signer here in the program signers, which is the program address. Nice. And the upgrade authority, which is the second signer in this program signers. I don't know why they put it into one variable here if they then split it like that anyway, but you know, fair enough to then more easily be able to say those are the signers when we create the transaction here. So yeah, that's the interesting part, essentially, the program address. I mean, we can look into this as well. Now we're getting somewhere else in the code. Program address. Here it's just an address. So for this, it's irrelevant what I put in here. Nope, it's not, because, and that is the interesting part, the address is actually here created with the system instruction, create account, full stop. And there we have it. That's basically giving me my answer already. Basically, I just need to swap out this part. Get rid of the system instruction, create account, and insert a create account with seeds. And then play around with the signers a bit to make it actually work. But yeah, that should be doable, because all that does is create me that account with the system program. Upgrade a loader state size of a program, which is, let me guess, 32 plus 4, which is 36. Oh, it's dynamic? No, 36. There we go. You can check the state. Either it's uninitialized, or it's a buffer account, or it's a program account. That's the interesting part. Or it's a program data account, then it has that. Yeah, so basically it's the system program create account instruction, and then an instruction to the BPF upgradable loader, which takes the max data length as an argument and needs those accounts. Pretty simple. And what the program itself does, we could also have a look at, but I guess we gotta stop somewhere. We can of course look at the program source code itself of the BPF upgradable loader and see what it does. But for this video, I'm not so interested in that. I let that program do its magic. Basically what I imagine that it does is just it copies from the buffer into the executable, so the program data account. We have the payer, we have the program data address, we have the buffer, and we have the program address. So it copies from here to here and then says that this is an executable now and links to this program data address. And this guy is paying for all of this fun. Yeah, fine. I mean, works for me. Basically, that's what I need to change. So, should we create ourselves our CLI in a way that we can deploy with createAccountWithSeeds? Or are we happy enough that we would theoretically know how to do it? Nah, we're not happy with that. We do actually want to prove that we can do it, because what's the point of theoretically knowing if you can't actually make it work? Sadly, there is no implementation for that in the Solana CLI because, I mean, it's a very edge use case. Usually you're just happy providing a normal key pair, but I'm a nerd and I want to be able to do stuff differently if I choose to do so. So yeah, I'm going to change stuff. I don't have the intention of making this super nice and fancy with a command line argument that I pass through everything, because that just seems like a lot of work. I could potentially do it, but this should be a somewhat short video and I just want to prove that it's possible. Somebody else can, if they want, include it in the CLI and make a pull request. Again, it's just a very edge use case. I'm not even sure if they would accept a pull request like this, but all I'm saying is I'm not writing the cleanest of codes. I'm just gonna write code that gets the job done just for now, just so I can do that. And yeah, I think the easiest is to work backwards from here. But before we can work with that at all, before I'm writing any line of code, it would be good to see if I can build this thing that I downloaded from GitHub. So I'm gonna do just a print line in here just to see that I'm executing this code. So let's try and do that. Let's see how easy it is to just say cargo build, maybe in release directly. Or do I want to, let's just do build. Let's just do it in debug. That's fine. There we go. Works. We were able to build that. And now, so in this folder, which is a few folders out, I have my Solana, which, you know, has all of those things which I can execute. So basically I can do the same thing that I just did before this Solana program deploy. Wait, hold on. A Solana program deploy, but with my version of Solana. So this path, this should also work. Yes, also works. And it does not give me my log because I only log this if I deploy it to a new address. But let's say I deploy it to a new address. Why not? There we go. Newy. If I deploy it to Newy, then we see we are executing our own build. Okay, so that seems to work. I can build and run my own code here. Well, my own code. The code that I cloned from GitHub, but I can change it. So let's work backwards from here to the place where we want to go. So basically, I want to change this to a createAccountWithSeeds. That will require different things. More arguments. What you take? The from pub key, the to pub key, the base, the seed, the lamperts. Hold on, can I just put this here? So the from pub key, that's the payer, that's fine. The to pub key will be the program address. We will need to somehow change that, but for now, program address seems fine. And then lamperts and space and owner. Lambert space owner is this, but what we're missing is the base and the seed. So in between here, we need the base and the seed. And the base, I'm gonna make it simple for myself. I'm also gonna take the payer, or actually the authority better, the upgrade authority as the base. And the seed, well, I could parse that in somehow with, you know, just a string. I can now, with this CLI, only deploy programs with the createAccountWithSeed. That's fine. Again, I'm not saying I'm gonna create a nice CLI that can be productively used. I would just say I'm gonna use this once for this one particular use case. Anyway, seed. There you go. Wonderful. And that's basically all it takes from this perspective. Then I create an account with seeds. Of course, the program address now needs to be exactly this thing here that matches the create with seeds address with the base, the seed, and the owner. The owner will be the program, which is this guy. the BPF upgradable loader. The seed will be whatever I put as a string as a seed, and the base is going to be my authority. Yep, good enough. Let's somehow make that work, that we figure out that part and put in a seed. So where did we use that thing? Oh no, I used this in tests and everything. This is gonna break everything now. That's one of the issues I have with Rust. I can't have a default option for this. And if I build it, it will break in many places. Let's just see if I say program. Whoa, wow, okay. So this is actually not used that much as I thought. Then that's fine. So here I add the seed. That's the easy part. Hard coding stuff for the win. Anyway, so the difficult part is now to get the program address not as a signer. So this thing itself doesn't sign, only the upgrade authority and the fee payer will sign. So the fee payer will sign and the program signers. You know what? I'm just going to change this. Just going to change this program signers. Leave it the same. I leave it as this option of this slice of signers, but I will remove this one, the first one, as the program address. I'm gonna change this to 0, remove you from here, and here take a program address that I will pass in additionally in this function after the program signers, which will be one program signer, the program address, which I force you to give me as a pub key. Okay, and now you're gonna probably complain. There are 2 areas where we do this, so maybe I will make it an option for a pub key reference. Fine. Such that in the place where we just write buffer, we also have none for the program address, but in the place where we actually do the program write and deploy, for the initial deploy, there we have the signers and the program address that I will get from somewhere. And the signer, I will steal this first one from you, from the program signer, because you won't be a program signer. The program address will not need to sign this one. But where do I get the program address from then? There, I have the program pub key. I'm just going to use the program pub key. I already have a variable for that because that's what I get from the CLI. If I just say program ID and put the pub key, then that's the one I am going to use. The pub key here, the pub key here, which is a pub key. You need a reference. Yeah, fine. Assuming pub key is derived with seed program with update authority as base. And if it's a signer, it will actually not work, but I will, whatever. Because I stole the signing of this. It's just, I'm just gonna make it work. I'm not gonna update the CLI, goddammit. Just for now. Yeah, and we don't error. And I guess that's already it. That's already all the changes that I need to make to the CLI. I have hard-coded this seed in here now. I could drag the seed out actually. So let's do a, and I'll pass in the seed here as well. Whatever, it's just temporary. And here you complain about what exactly? You found an option. Well, also here then unwrap lol. Because I'm sure that I have provided this. Does it build? Absolutely not. Oh yeah, I said it's an option. Okay, fine. Have an option. Better? Oh yeah, because now you need the seed here. True. Seed here is none. If I ever process write buffer, that's gonna fail. We'll fix it when we get there. Cool, but it builds. Nice. Let's just run it, and it will obviously not work, but what would happen if I run it? It would work, I guess, because the part that I changed, I create a new one. So what if I were to build in the brand new? There we go. Program will be deployed to this address. We're assuming that the pub key is derived with the update authority as base, program as the seed, and the upgradable loader as the owner, which obviously this one wasn't. And then it just crashes because it's not successful. It did build the buffer though. We saw those transactions being sent for the buffer, and we could recover the buffer address that it created for us. So yeah, this is expected behavior. So now we need to get the right program ID. That's just the right address, and test with that. That part I'm gonna do in TypeScript though. Maybe even try it in the new Web3.js maybe, because I know how it works with Web3.js. I don't know how it works with the new Web3.js. If you don't know how it works with the old Web3.js, I linked the video in the beginning. So we don't actually need a signer. All we need is the authority, the owner, which is an address of the BPF upgradable loader. There we go. And we need the seed, which is program. With those things, we should be able to create this account, like derive this account. There must be a create instruction. That's all giving me the instructions. Usually I'm used to having it in pubkey. So in what's now called address. Create address with seed. It's in Web3.js. Wonderful. There. That thing. Base address, program address, seed. Gives me a promise for an address. Shouldn't be too complicated. Base address is my authority. Program address is my owner. Seed is the seed. Await this. Hold on, that's not how you await in TypeScript. Here you say this await, and then we have address. Log me the address. Oh, I can't call it address. Cool, I call it account. This address is now a function name. That's maybe a disadvantage of the new Web3.js. I sometimes call my local variables address. Sure, but let's just not do that. And then run this with seeds. And that's the pub key that we need. So let's do the same thing, but put that very pub key here. And see, we're building the buffer and... Ha! Whoa. Wait. I fucked something up. Or maybe I didn't. But that would be weird if it would actually let me deploy to this program ID, which is my authority. I think just the printing of this went wrong. I think it worked. Here I say I'm deploying to this address, and then program ID. Let's see, where does it have that from? Aha, here we have it. Where the program ID is the program signer's 0 pub key to string. Obviously, because I removed the 0 from the signers, it's now printing my authority. So the second one, it expects the program IDs to still be in the signers, which it's not anymore. But yeah, that's fine. It's just a print. So ignore that line. But this is interesting because this is the transact. Wait, hold on. I can't show this because I'm on. Let's do it the old school way then. Basically, we see the system program is called. We don't see which instruction, but this will be the createAccountWithSeeds. The BPF upgradable program is called, which again invokes the system program for something, and then we return success. So basically, this has worked. I deployed this program to that address without this guy being a signer. Nice. I have only one signer in my transaction. Pretty cool. So we managed to do this thing that we said we were gonna do. Let's prove that we can do this on DevNet as well. Should not be too difficult, because all I need to do is say, I go to DevNet and I airdrop myself some sol. And then I do the exact same thing as before, writing to the buffer, finalizing, boom, ignore that, look at that, on DevNet, this transaction, we have the one signer, this guy is writable, this is gonna be my program ID, and this was the buffer account, which was emptied, and this is then the executable. So if I click on that, it will tell me this is a program that is executable, and the executable data is on this account. And the authority is this guy. Pretty cool. And here we can now look at the instructions. We do create account with seed. Yes, that was the goal. The seed was program. And it just did all that. And if you think this is all magic, watch the video on create account with seeds. Why that suddenly works. It's pretty cool. This create account with seeds is pretty cool. Deploy with max data length. the program account is this one, even though this is not a signer. How fun is that? It just worked. Create account. I was able to create that account with that size, 1.5 sol, because it's a big program, because Anchor. And yeah, we closed the buffer account that we had already assigned to us, and we created the executable account. There, that makes sense. And since that is a PDA of the BPF upgradable loader, so of this program, we can call the system program create account without having that thing as a signer, because it's a PDA and therefore the program can sign for it. So this invocation was an invoke with seeds, and then the system program also accepts it as if there was a signature for it, basically such that every program will always have one executable that is always at the same place. Then we don't need to worry about it. But yeah, the BPF upgradable loader program takes care of that. Yeah, so cool. We can do the thing that we said we want to do. Nice. Create account with seed. And you will be like, well, Andy, why is that any good? Like, what's the point of all of this? Why did I just spend 45 minutes watching this video just for you to figure out how to do this? What's the point? You still don't have any vanity address or anything. This is not a vanity address. This is just a random address. Not random, it's a specific address that we derived with specific seeds, and we can't change that. We can't change that. We can't change that. I mean, yes, we can play around with the seed a bit. Yeah, we can play around with the seed a bit. So instead of saying program, I just need to provide the right seed that then gives me a more interesting address. And because this whole derivation is more efficient than having to first, from a private key, derive the pub key, base 58 encode that and see if it's an interesting pub key, I now just iterate through some seeds and check that account, like derive that, which is cheaper, so we can have more iterations, so we can find addresses that are longer. But that is a topic for a future video. I think for now I'm happy with this. I'm happy having figured this out. We don't need to do everything in one day. Rome wasn't built in a day, so we also don't need to find a nice vanity address today. But it was great that we figured out how that final transaction from a program deployment actually is built. I hope you learned a little bit about Solana programs today. If not, then you already know stuff. Great. But it was actually, in the end, it wasn't so difficult. It's literally just changing this. And yes, now I can, write the CLI properly in a way that I can just enter the seed as a CLI command and whatnot. But I'm too lazy for that. But yeah, it's cool to figure out how to deploy a program with an address that we have from createAccountWithSeeds from the system program. That's pretty cool. I enjoy that. So you can be looking forward to the next video, where we're going to actually derive a bunch of addresses to find a vanity address with like 5-6 characters that we like. Because for now, my limit is usually 4. I can't do more than 4, and that also just if it starts with A to H. So make sure that you are subscribed, like this video if you actually enjoyed it, watch some other ones, and I will see you around for the next one. Till then, bye-bye. And deploy your programs to accounts that you derived with seeds. Yeah. This is so useless, but I really enjoy being able to do this. If that's my way how to learn Solana development, then that's my way how to learn Solana development. Here we are.